Algebra 1, Lesson 4.1, Coordinates and Scatter Plots. We're plotting points in the coordinate plane beginning on page 203, and then we're drawing scatter plots representing real-life situations. Handful of definitions to start. The first one is a coordinate plane. Coordinate plane is formed by two real number lines that intersect at a right angle. When you draw a coordinate plane, this is what you're drawing. They extend infinitely up and infinitely down. This is your y-axis, the one going up and down. Sometimes students misplace which ones are which one's x and which one's y. One way where you can remember which one's which is you can, instead of having this right here, you can make it look like a capital Y. That's one way some students remember which one's which until they start getting the hang of it. After you do this several times, you won't have to think about that too much anymore. You're going to know which one's Y, which one's X. The other one is the X-axis, this one going across here. It also extends infinitely to the right and to the left. We have dealt with number lines already in this class. We know going to the right is your positive numbers, just like with your Y-axis going up is your positive numbers. And with your x-axis going to the left, we know those are your negative numbers, just like with your y-axis going down is your negative numbers. In the middle is considered is something called the origin. It's both its x and y value are 0, 0. We'll talk more about what the x and y values are in just a minute. But this is considered a coordinate plane. Something else about coordinate planes that's not in your notes that you need to understand is something that you learned before you ever walked in this class. This over here is quadrant number 1. It's always written in Roman numerals. Then it works counterclockwise. If you go to the left, this is called quadrant number 2. If you don't know this, copy it down right now. Then go down, quadrant number 3. Again, notice I'm writing them in Roman numerals. That's the way it's written. So which leaves quadrant number 4, and in order to write quadrant 4, you need to write it as an I and then a V. Good. Quadrant 4. 1, 2, 3, and 4. There'll be a time when you're asked which quadrant is said point in, and you'll have to choose the correct quadrant. The next definition is that of an ordered pair. It says each point in the coordinate plane corresponds to an ordered pair of real numbers. Inside of this coordinate plane, where you have an x and a y axis, the arrows represent that there's an infinite amount of numbers. If we plot the point 2, 3, for example, this is your x-axis. So if you're going to go 2 times to the right, so from 0, 0, you go 1, 2, and then the second point is, or the second number in the ordered pair is 3. You're going to go up 1, 2, 3. The point is going to land right there at 2, 3, because that's your x-axis, and this one is your y-axis. That point right there is called the ordered pair 2, 3. There's an infinite amount of points in there. Now, you can look at this and notice I don't have any of this scaled or anything. I just sketched it freehand. But you can count that we counted 1, 2 right there to get to 2, and we counted 1, 2, 3 to go up to 3. But in between 0 and 1, there's an infinite amount of points. You can never count them. You can never figure out how many there are because there's 0.01, and then there's 0.011, and then there's 0.0001. There's an infinite amount. Okay, most of the time in here we'll deal with integer numbers like what's up there, or we'll deal with numbers, fractions that are just a little off on integers. We won't go too far into it because remember, if you can do the small numbers, you can do the larger numbers or the longer numbers in this case. But the point itself, the ordered pair, is x, y, 2, 3. And we'll talk about which one's which in just a second. The x coordinate, and yes, I have the alphabet written up here. The first number in the ordered pair is the x coordinate. If you forget which one goes first, it's alphabetical. Notice x comes before y. X comes before y. So again, that point that we looked at a second ago, 2, 3, at 1, 2, 1, 2, 3, its x value is 2. and its y value, which we'll look at on the next definition, its y value is 3. So 2, 3 is its ordered pair. Again, it's alphabetical. The second term is y, or the second point, the second value in the same point is y. And it's alphabetical, the second one. Okay, this is a definition that people get confused a lot. Okay, not because they're doing it wrong necessarily. Just if you're asked what is the graph of something, people get it confused, because if I tell you to graph the point 2, 3, the same one we've been dealing with, you're going to do this. You're going to draw a graph, and then you're going to consider this the graph. That's what people think, that's the graph. That is not the graph. That is simply the coordinate plane, or the Cartesian plane is another word for coordinate plane. Cartesian plane, because it has different directions like a compass. Okay. This is the graph of this will actually be at 1, 2, 1, 2, 3. The graph is this right here. That's the graph. The point on the plane that represents the point that you're trying to write, 2, 3. Notice that's what the definition corroborates. It says the point in the plane that corresponds to an ordered pair x comma y is called the graph of xy. So that's the graph, the point. We will very shortly get to where we are graphing linear equations. We're going to start putting equations through here. This is something that you may or may not have done in a previous class. We're going to be able to do that. The graph of what I just drew is the line itself. It's not the plane that you put it on. And then a scatter plot is a graph of pairs of numbers that represent real life situations. It's a way to analyze relationships between two quantities. So if you have the same Cartesian, the same coordinate plane, notice I kind of took out the second quadrant because I'm not going to use it, and I took out the third and the fourth quadrant. So we're really only going to focus in the first quadrant, which means we're only going to focus in positive numbers, both x and y positive numbers. So a lot of times when it comes to real life situations, you'll deal with a graph that looks like this, or a plane that looks like this. It doesn't necessarily mean that the numbers over here are invalid. They just don't make sense to use some of the numbers over there. That's the reason why you'll focus on the positive values. So for example, if you're talking about heights and weights of football players or something like that, on the x-axis, which is the one going across right here, you might say heights right here. And on the y-axis, that's the one going up and down, you might say weights. And again, this is all stuff I know you guys have seen before, heights and weights. So if the player is 5'5", so that's 5 foot, and then we'll go right here to 6 foot, and then we'll go right here to 7 foot. Now there's a lot of, there's a lot of measurements between 5 feet and 6 feet. So that'd be like 5.5 feet, which is 5'6". This would be like 5 3/4 of a foot. That's 5'8". And so on and so forth. But when you put an x value, like say the player's height is 5 feet and his weight is 150 pounds. So when you graph that, it'll look like that at 5 feet, 150 pounds. Where if a player were 7 feet tall, he might be 270 pounds at 7 feet tall. I know that's an extreme sounding thing. But that would be a point that would represent both 7 feet and 270 pounds. A scatter plot will have other numbers or other values mixed in. And we'll look at some examples of those in a second. Here is example number 1. It says plotting points in a coordinate plane. If for some reason when I make these copies, I didn't do this on purpose, but when I make these copies, it prints out things plotted every now and then. You were supposed to plot these yourself. However, make sure that you're at least paying attention to how they got the plots. It says plot the point A, B, and C. A's value is -2, 3. B's value is 3, -4. And C is 0, -2. Remember, it's x, comma, y. If you ever forget that, think alphabetically. It goes in alphabetical order. -2 is first. So on your plane, your x value is going to go from 0. It's going to go 1, 2. And you can see that it says to plot the point A, negative 2, 3, start at the origin at 0, 0, move 2 units to the left since it's negative. Its x value says to go left 2 times. And 3 units up because it's positive. So from there, you're going to go up 1, 2, 3. And that's where that point comes from right there, A, negative 2, 3. Do the same thing with point B. Its x value is 3. So you're going to move 3 units to the right. So 1, 2, 3. And it says negative 4 for its y value. So you're going to go down 1, 2, 3, 4. There is point C right there, 3, negative 4. And again, I know all of these are already plotted for you. Pay attention to how they got those plots, though. That's what's important. And then the last one, 0, negative 2. Notice 0's x value, x's value is 0. That means you don't go left or right at all. But negative 2 tells you to go down 2 times. Since its y value is negative 2, you go down 2 times, and that's where that point comes from. Okay, here is one that you do have to do. Turn the page over and sketch yourself a graph. It doesn't have to be perfect. Graph these 1, 2, 3. Graph these 6 points real quick. Should be very easy for you. Take about 45 seconds. Okay, let's take a look at it, everybody. You don't want to have, when you're drawing this right here, you don't want to draw out and list all of these numbers and draw them text. It takes too long to do that. Only draw what you need. Notice as you're looking at all these numbers, the largest absolute value on here is the number 5. So you don't have to go in any direction past the number 5. Don't show anything that's not necessary. Letter A says 2, 1. This is X, this is Y. So go on your x-axis, go to the right 1, 2 times, and go up 1, because y's value is positive. That's A right there. B's value is 5, negative 3. Again, that's x and then y. So go to the right 5 times, that's this value, and go down since it says negative 1, 2, 3. That's B's value right there. C's value is negative 3, 0. Again, x comma y. Don't forget the order they're in. That's the mistake people make. They'll put the 0 first and then the negative 3. That's not right. Go to the left since it's negative. That tells you to go left this time. 1, 2, 3. And then don't go up or down at all because y's value is 0. That's C. So that's where A, B, and C should be. I'm going to have to reuse some colors because I only have 4 of them. Let's go to the next color real quick. D's value is negative 2, negative 2. It's not going to make a difference which one you put first because they're the same. Go to the left since it's negative 1, 2, and go down since it's negative 1, 2. That's D. Oh, I have another color. I'll use the black one. That one works good. Okay, E is 0, 4. Again, X comma Y. Don't go left or right at all. It tells you not to move at all. 0. Go up 1, 2, 3, 4. There is E. And then one more, F. Maybe I can make this purple one work for me. F is negative 2, 3. Negative 2 is the X value, and pink, I guess. Y is 3. So go negative 2 means left 2 and up 1, 2, 3. There is C. Not C, F. There's F. So that's where all your plots should be. Anybody have any questions about how we did that? Should be easy for you. Okay, then it told you to plot these points, and again, I apologize that they were all plotted for you already. But if you are having any issues, this one tells you to go to the left 3 times. This one tells you to go down 2 times. This one tells you to go to the right 4 times. This one the 0 tells you don't go up or down at all. This one tells you to go to the right 1 time and to go up 4 times. Those are your directions. This one tells you to go to the left 3 times, and this one tells you to go up 2 times. All they are is directions, left or right, and then up or down. And it says making a scatter plot. We have this basketball team. It says number of NCAA men's college basketball teams is shown in the table. 95, 6, 7, 8, 9, 99, and 2000, showing how much there are. It says let M represent the number of men's teams. This is something you have to fill in. And T represent the number of years since 1995. Make sure you copy down this one just like it is, the number of years since 1995. Because you want to see the number of teams change, or how the number of teams change over time, put T on the horizontal axis. The horizontal is the x-axis. And put M, or the number of, M represents the number of men's teams, put that one on the vertical or the y-axis. It says choose a scale. Use a break in the scale. A break is simply drawn with, when you're drawing your plot, a break just simply looks like this. You just draw it like that to where you don't have to show all of the values below 800 because you're focusing between 800 and 950. You already have this part right here done for you. Okay, and the last part that you need to get is what everything represents. Notice it stays fairly consistent for those first 3 years, fairly constant or fairly consistent. And then it starts to increase gradually.